Hello, 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 hello. Okay, fine. So, hello everyone. Today is my day 24 of my C++ DSA learning. Okay, so today is our day 24 of C++ DSA learning. In today's stream, what I will be doing, I will be revisiting some old problems in a good way, like in a smoother way compared to yesterday's stream. And after that, I will be trying a new problem. According to the roadmap that I am following, revisiting today I will be revisiting two problems, and after that I will be trying one new problem according to that roadmap. So yeah, and the first revisit will be of that problem that I have told that I was, in which the dragon was not good in the previous stream, and but today we will go through it and yeah, understand it in a good way. Just let me give the link in the Discord server. If anyone is online, then he or she can join the stream. Stream. Okay. think the voice is coming in a good way. Yeah. So the first problem that we are going to revisit is, yeah, will be this problem that's name is power of x into n. Okay. Power of x raised to n. Like yeah, and yeah, our rating has increased a little bit. I think like around it was around 33 lakhs, but today it is around 32 lakhs. So yeah, let's see how the flow will go. Today, what I will be doing, I will be using Scali draw mode to yeah, give the visual representation of how the code is working, or we will be doing a dry run of the problem in this problem, okay, which name is power of x into n. And I will tell you first that why that code, why we were not using that big of n time complexity approach, because today, what I did, I tried to understand the problem. Like after lecture, I was unable to understand what is given in the problem. But today, what I did, I go to the chat GPT and ask about the problem, how the problem is working, what is the intuition behind it, and yeah, what is the logic used here, and why not you use the big of n, you know, big of n code, the code in which it runs for n operations. Like if suppose 2 to the power, yeah, 2 to the power of 5, then we have to multiply it 5 times, and in case 2 to the power is 100, then we have to multiply the same value for 100 times in the approach where n operations were happening. Okay, and suppose, like, see, it can go up to 2 to the power 31 to minus 2 to the power 31, means it can go up to, there can be billions of, the power can be in billion. Like suppose, and yeah, there was also another thing that yesterday the string got cut in between in the last part of it, but we have completed the problems and revisit yesterday. Just it was cut when I was going from the stream, and yeah, because of the electricity, there was some electricity issues going on. Okay. Now first I will name it as day 24 of yeah, day 24 journey. And let me see how the display is showing the things. Just wait a second. Okay, nice, nice. And yeah, I was going to start the stream earlier, but there were again some electricity issues going on. So because of that, I was unable to do the stream earlier. Like it was planned to do the stream at around 7 p.m. or before that, but the light was gone, and because of that, I was unable to do it. Day 24 DSA journey. So see, when we take any number, like uh, suppose 2 to the power of 5, okay, then it will run for 5 operations. Like here, it will do 2 into 2 into 2 into 2, like this. Okay, it's not looking that good. What I will do, I will let it like this, 2 into 2, and copy it, so it will look good. So 2 into 2. After that, I will load all these and copy it, and here I will paste it. Okay, so yeah, 2 into 2, and here again. It's not looking that good, man. Let's make it a little bit clear. Okay. Okay, leave it. See, 2 into 5, 2 to the power of 5 will be 2 into 2. Like 5, it will happen 5 times. Okay, then it will give the result that here 2 into 2 is 4, into 2 is 8, and 8 into 2 will be 16, and okay, and 16 into 2 will be 32, and 32 into 2 will be 64. Okay, yeah. So it will give 64 when it will be 2 to the power 5. Okay, the code will run for smaller values, like in which the power is not that big. But see, when the code will be, when the power will be like this, 2 to the power 1, suppose 2 to the power 1 million. Okay, like this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 7. Okay. Suppose it is equals to 1 million, then will we do like a calculation like this, 2 into 2 into 2, like till it reaches 1 million. So I think the computer will also not try to do that. The computer will try to find another way in which we can do the same thing by not doing doing this operations like 1 million times or 1 billion times. And yeah, and according to this, the value can reach, according to the problem, the value can go up to, more than 2 billion power. The power can go up to 2 billion. Okay, more than that. So in that case, uh, will will we be doing like that much multiplication? So it will take so much time, and even for a computer. So why we use binary exponentiation for that? Because in binary exponentiation, instead of doing this, we can do the multiplication. Suppose it is around 200 crores. Okay, like the power is around 200 crores. So okay, so we will be doing 2 into 200 crores, like 200 crore times. We will not do that. So instead of that, when we will be using a binary exponentiation okay, method, then instead of doing this, we can bring it down to around 30 steps. It can happen in 30 steps. according to the when we will use binary exponentiation in that. So let me open the chat a bit so that I can have a reference of the like the words which will be used. So it will be easier to explain you guys what the things are happening here. And just wait a second. Mhm. How much time can divide? Like in normal method, see, when we will do the things, in normal method, suppose it is maybe it is equals to 200 crore, okay? Like suppose it is equals to 100 crore, okay? The power is around 100 crore. So in that case, we have to do, we have to do 1 crore, sorry, 100 crore steps, okay? But in the binary exponentiation method, we can do it in 30 steps only. See the difference: 30 steps and 100 crore steps. Okay, I will write it here. 30 versus and 0 0 0 and 0 0 0 and 0 0 0. See, 100 crores are like that much steps. Okay, 100 crore will be equals to that much step, and you can see the comparison. 30 is very less in comparison to one. Okay, like 100 crores. So by using binary exponentiation trick, we can bring down the calculation and make it faster by using this. And instead of doing 100 crore, sorry 100 crore by times multiplication, we can do it in 30 steps. Okay, so what is given here? What we will do inside this, which I wrote yesterday. Okay, now I will tell you that why we have written this instead of the things that I will show you the dry run using Xcali today, like in which I will be showing how we can break down the powers into exponential exponent into half, and how we can get to the answer by doing that. Uh, it's got stuck a between. I don't know why. Okay, it's not zooming out. Okay, I think it cannot go less than 10. Okay, zoom the minimum zoom and zoom is 10%. Okay, so now what I will do, I can yeah I can use the area here. It's draw line. Okay, now what we can do here, hmm, hmm, okay, maybe we should use this color. I think this will look good, a little bit clear, or in the screen it will be visible more. So just wait a second, let me check that. Like I will be taking two examples. Okay, when the power will be odd and when the power will be even. Okay, so suppose we have given like in case one. Okay, in case 1. Okay, we will name it case 1. Suppose the value given is equals to 2 to the power 6. Okay, and in that case, first we will take the binary form of 6, like here it will be equals to 110. Okay, I'll show you 6 in binary. I think internet is a little bit slow, or maybe okay. Hmm. 6 in binary. Why it's not showing that, man? 6 in binary form. Okay. Don't know why it's not. Okay, it is showing here 110. Okay, so it is equals to 110. Like 6 in binary is equals to 110. Okay, when we convert 6 into binary, it is equals to 110. And you can see we can break down the powers like in binary. Let me. Uh, Hello, man. Hello. Welcome to the stream, man. Okay. Which question are you solving? I am just revisiting a problem that I was, I have done yesterday. Just the dry run was not that good. So today I tried to understand it with the help of ChatGPT. After that, I understood the problem. Now what I am doing, I am just taking two edge cases and explain there how the things are working. Like when the power is odd, when the power is even. Like what here I am telling the method by using which we can uh, raise any number to the any power by using less steps. Okay, like this is happening. I think you know this question. You are already at a different stage, man. Like I have understood it today in a good way. Just was doing the okay. Okay, okay, okay. Yeah. So here it will be like okay, like in binary representation, we can say it like mhm, like it is equals to 2 to the power 0. First we do it like this, then 2 to the power 1. Here it will be 2 to the power 1, and here it will be 2 to the power 2. Okay. So when we exclude the bits which is equals to 0, we exclude that, and when we break down the powers, like 6 into like this manner by 2, so it will be equals to 2 to the power 1 and 2 to the power 2. So it will be equals to 2 plus 4. Okay, like this. Like I know these things, just the explaining the things in a way like using in English is it's a little bit difficult. Okay, so we can break down the 6 like this, like the power like this. So now what we will do? Okay, yeah. It shows that it shows the powers of 2 at every bit. Like we go in the this format like right to left, and it shows the power of 2 by increasing it. Okay, like here it is 2 to the power 0. Okay, and when we will on the this on this bit, then it will be equals to 2 to the power 1, because in binary when we when you see that 2 in binary. Okay, so 2 in binary is equals to 10. Okay, let me show you 1 and 0. You can see it here. So that's why here it is done like 2 into 1. After that, when we will do 2 into 2, so it will be equals to 4, and 4 plus 2 will be equals to 6. And that's why we have break down the power into like two steps here, like 2 plus 4, because we have taken 2 to the power 1 and 2 to the power 2. Okay, so for this case, what we will do now, we will start the thing that is written in the code. Like here, we will take answer. Okay, x and the like power. No, x will be the base, like by which with which we are doing the taking the powers off, and there will be another variable named as, like, we can name it n here, like, or maybe bin form, but it will be longer. We will take the name as it is written like before. We can use n for that. Okay. So at the same time, I am watching the things at the phone, so that you know we will not switch in between, like in a faster way. So yeah, it will be easier to explain like this. Currently, ChatGPT is open on my phone, so I'm taking the help of that. So because in dry run, sometimes I in between forget the like variable names or things. Suppose answer we initialize it with one, we have already understood that, and the power x is equals to, okay, x is equals to 2 here, like it is equals to, I will mark it here, it is x. Okay, and it is 6 is n. Okay, the power, and after that, see what will happen. And we have also converted the n into this like long, because when we will convert the power from negative to positive, then it said that it can be, it can overflow and it can give the wrong result. Like the integer will overflow, according to that it said this thing. And we have initialized the answer with 1, okay, so that we can multiply the values here. If we will have multiply, initialize it with 0, then you cannot multiply it with any value. It will eventually become 0 because of that. And when we will multiply for the first time, you already know, then it will multiply by itself. Okay, like let's show you here. So first we have started like in the starting, the answer is equals to 1, x is given to here, n is equals to the power is equals to 6 here. Okay, now in round 1, okay, suppose, okay, I will name it step 1. Okay, step 1. What we are doing in step 1, see. Hello, 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 man, hello. Welcome to the stream, man. Uh, how's your day going, man? Is my voice coming or something is wrong? Okay, so how was your day? What did you like? I have seen that you don't give any updates in the Discord, man. Like, aren't you learning something on a daily basis, or what? Like, what's the case? Or just you don't feel good like sharing the updates? Like, what are you doing on a daily basis? You love to keep them secret. Okay. I also didn't knew about Discord, but a few days ago, I there was a guy who invited me to his Discord. Then I got to know about Discord. Like, just we have already created our account. Just you need to share your daily progress here. Like you will write like day has like day 1 or day 2, and what I have done in day 1 or 2. Then just then just send the message. That's simple. You can share a project there also. Like if you have created any project, then you can share the link of that here. Okay. Or if you have even completed a part of a project, then you can maybe you can also share image or file or link anything that you want. But I think it's good than WhatsApp. Like in WhatsApp, if like I was supposed to like create this, if I wanted to create different groups, then like different categories, then in the WhatsApp I will have to create so many groups. But here we can just create n server and there will be so many groups here. Okay, like so many channels and categories. We can go into the categories. So basically, you're telling me that I want, if I want, I can share my daily progress on your community here. Yeah, yeah. I'm telling this to everyone, man. Just when the community is new, like people don't know about what they should share or what they are doing on a daily basis. Should they share or not? Because many people, I don't know, like maybe some people are doing some ghosting or just they are active. They don't want to. send any message, or maybe at not at the right present time. Maybe I haven't explained them what is the community is about. Like there was a guy who has started already started sharing the updates. Like he was the first or second guy who joined the Discord, but like from some days he is just a little bit busy, so he will be sharing his daily updates, like what he have done. I will be also sharing a project when I will have created a project or a part of a project, okay, which I feel that okay I should share that and get reviews on that, like how is it or what thing should I improve, so you can get reviews on that. That's what I want. Or you want any help from people, you can ask it here. But I have seen that Discord is not, the people in the Discord are not that much active. So yeah, we want also, I think we want more good people like who can be active in Discord, or like have interaction with each other, and yeah, help each other. Like I also want to help everyone like here, but time is not allowing that, and I also don't know about everything. Like someone is doing app development and I'm doing web development, then how would I know that? Like that's the thing. Like if you know something about something, then you can help others also there. And by doing that, I think you will refresh your, the information will be refreshed again in your mind, and maybe you want help into something, or you have any doubt, any you can take any minor doubt also. Like there is a minor doubt in anything, in a small to small thing or big to big thing, you can ask about it. If anyone will know about that, then you can do that. And it also creates a type of responsibility on you when you will share on a daily basis. Then after the next day, you will think that okay, today I will also have to give update to the people. Like there are people who are watching me, like what I'm doing on a daily basis. Even if there are two people watching only, but yeah, it will matter. It doesn't mean to be like if there are 11 members, all 11 members should be active there and review our things. The people who will be maybe serious, or maybe who they are not getting time, they will also interact and give reviews or share their things. Just the setup is new. Because of that, the problem is going on, man. So what do you feel about it? Like, are you going to do that like on a daily basis? You are going to share your updates, you know. So it will be a track of yours, like what you are doing on a daily basis. I don't know how I can explain this to you, but yeah, shortcuts of Excalibur right now, like how to switch color, how to control font size. Okay, I also don't know much about that, but yeah, we can try. I have used it a little bit. So what you asking whether can shortcuts like how to switch color? To switch color like of anything like the text. Okay, you can say the color of the text, or the pencil which I can use, like or draw a line, or shapes. Just you can pick the colors like given here. Also you can pick the color from here. There are not so many colors available here. Like we can write any hex code color here. Okay, its color like I think its color library is given according to Excalibur. Okay, like it's limited to these colors. And when you select a color, here, when you go here and you select any color, okay, like if I select this, there may be shades of that available also. And by doing this, you can select color. And if you want to change the font size, you can come here and you can select the font size, but it may appear, little. Like here, if I write it, I have selected large, but it's not showing that, much big. I have to zoom in to see that. But what you can do instead of that, you like you can enable the selection tool here, like it is given here, and like click on this and just make it bigger like this. Like the font will appear bigger when you will have zoomed it like handed yeah, zoomed it to 100% here. But right now I have doing it like 10%. That's why. And yeah, I'm also using pencil because of that. It's showing like this. What do you think about this now? Like, is it? Have you understood the thing? And it is also a little bit difficult when you draw it using the laptop's mouse. Then it's become a little bit hard to draw the things in a good way. Instead of using a computer mouse or an external mouse. You keep asking the questions in between. Yeah, at the same time, I will be also completing the problem which I'm trying to explain to the people. So in the step one, pen tab. Yeah, but we was but just the thing is that we will have to purchase it. Like there are so many tablets that teachers use to explain things using Excalibur, or maybe there are so many things like you can uh, buy an iPad, or you can buy this drawing tablet which is very famous. Okay, yeah. Like I was also thinking to purchase this. Like it's a very good drawing tablet. Like you will use the pen like you will draw on the board and it will show on your computer or laptop like this. It works like that way, in that way. But it's just you have to put some money in that. The range of it is between around like I think 4K to 12K or more than that. Yeah, you can use it using mouse also if you have an external mouse or something. If it feels easier, then it's good, man. Just wait a second, I will be back. Again, there's a full cone coming. Okay, man, just a break. Because of the phone calls, the stream things get a little bit disturbed in between. Oh man. So now what we will do, we will try to just I think we should focus on this first. Now what we will do, I think we should focus. So in the step one, then yeah, in the round one, see, n is equals to 6 and last bit is 0. Okay. So, and yeah, we also don't want the current bit like here. You can see it will run for this like when, yeah, like here. When we do, take modulo of it with 2, then the last bit will be 2. Okay, like, last bit will be 0 here. So we will not update the answer now in this case. Okay. Yeah, answer will be equals to 1. Okay, answer will be equals to 1. And now x, what we have to do to x? Now we will do the, like x is the base, okay? Base, what does base means? Base is the numbers for which we are taking the, multiplying it with the powers of it. So base into base will be here, 2 into 2, okay? So 2 into 2, now the base will become like here. In the step 1, answer will be equals to 1, okay? And now base have become what? Base have become 4 here after like not multiplying it with answer. So it has now become 4. Okay, after that we have to divide it again so that we can get on to the next bit. And next bit is 2 to the power 1. Okay, so in that case, it will be equals to 1. So we will now multiply answer with base. So base is now step 2. Okay, let me write it step 2. Okay, in the step 2, okay. mm, like after doing this bit will be excluded. Okay, like it will be gone. Like after doing this, the n will become 3 also. Like if I show 3 in binary. Okay, don't know man why it's not showing there. 3 in binary is equals to 11. Okay, after removing that value, like here, the power of 2 here. Okay, and now in this step, what will happen in the uh, yeah. Now the n is equals to 3 here, like in the binary representation, it is equals to 3. And last bit is 1 here. So when we will, we will again, like take the modulo of it with 2, it will give 1 because the next bit is equals to 1. So yeah. So in that case, we will, something is got wrong here. Let me just see. Okay. After doing this, n is equals to 3. Okay. After this. So n is equals to 3 also, we will add that. And now the step 2 begins. Now n is equals to 3. Last bit is 1 here. Okay. So we want the current power of 2. Okay, sorry, we want the current power, and current power has become x is equals to 4 means 2 to the power 2. Okay. No, that's not. Let's 100. I was able to understand it in the evening time, but something is like in the diagram it feels a little bit heavy when I'm doing this. Don't know why it is happening. Hmm. Yeah. Okay, yeah. We want, we don't want the 2 to the power 1, or we want the 2 to the power 2, and after that 2 to the power 4. Okay. So how we will do that here? According to this, because we have, break down the 6 into 2 plus 4. So we want the powers into 2 plus 4 format, and we will not take the power when it will be 1. So first we have done this like here. Answer is equals to 1 and x is equals to what? X is equals to 4 when 2 to the power is 2. Okay. Like the base have become 2 to the power 2 and n is equals to 3. After that, in the step 2, n is 3 now. Okay. And the last bit of it will be 1 because 3 in binary is equals to, after dividing it like 6, it will become 3. So yeah, it will be equals to 3 and last bit of 3 is equals to 11, 1. So now we will also want the current power of 3 in this case, okay, like here. But might show it round 1. Okay, in the step 1, it will be, see, we have update the answer yet, okay. So now we will update the answer here. In the round 2, we will update the answer. So answer will now become what? Answer will become 1 into 4, okay, in this case, because the last bit is 1. That's why. So 1 into 4 will be 4. Answer has now become 4. And after that, we will again update the base, like we will do the square of the base. So 4 into 4 will be 16 now. Okay. Like it will be 2 to the power 4. Okay, here. Now it has become 2 to the power 4. Okay. Now, and now n has become 1 here. Okay. And in the round 3, like, and in the step 3, what is happening here? See, n is equals to 1. Last bit is equals to 1 because 1 in binary is represented with the 1. Okay, here. So last bit is already 1 when we will divide that. So n will become 1. After that, now we will also want the current power of 2, sorry, 2 to the power 4 here. So we'll do that. Like answer is 4 into 16 will be equals to 64. Okay, 4 into 16 will be equals to 64. Okay, and after that, what we will do? We will again do the square of the base, and 16 to 16 will be, yeah, will be equals to 256, and now x will become 256. Okay, but it will be equals to the power 2 to the power 8 because the values, the powers are multiplying, like uh, we are taking a half offense, and every time we are doing this, the powers are multiplying in this way. Like first it was this, then it became a double of it, then again double of the previous. Like it is working in that way, and now see it is done. Okay, and now n has become 0 after doing this. Okay, so we have to stop it here because you can see when n will be less than 0, then it will not run. Okay, n should be more than 0. That's the case. So in the answer, we will get what? We will get answer is equals to. But wait, man, just wait a second. See, there was a mistake. In the round 1, what will happen? answer will not be updated. Okay, answer will be 1 because we are storing the bit which is like which is 0. Okay, like we don't want the 2 to the power 1 value here, so we will not do that. We want 2 to the power 2 or 2 to the power 4. So for doing that, x has become 4 now. Okay, like 2 to the power 2 and n is now 3. In the second round, we will do we will do 1 into 4. Okay, like it will become 4. Yeah, answer will be equals to 4 here. And after that, x will become 16 and n is equals to 1 now. Okay, in the round 3, n is equals to 1. And yeah, last bit is 1. So now 4 in 16 will be 64. Okay, like here, we are written the answer with 64. And x has now become 256. So yeah, I think it was right. Just in that case, we have stored the 64 in the answer. So answer will be 64 because the value n has become now 0 now, so there is no number left to divide it with 2. Like 0 divided by 2 will give nothing. Like yeah, it will give 0. Okay, if I show you, like when I break this top power by dividing by 2 every time. So see 2, sorry, 6 divided by 2, first it will give 0 in the remainder. In the remainder it will be 0, but in the quotient we will get yeah, we have to take the remainder, so it will be 0. But when we do that, then the quotient becomes 3. So now we will do 3 divided by 2. Okay, in this case, it will be equals to 1. Okay, because 2 into 1 is 2. And the remainder, 1 is remaining. So we have added 1. Now we will take 1 divided by 2. So yeah, it is the last step we will do. And we will get 1 divided by 2 will be equals to 1 here. And that's how we are getting the values. And we will convert it into binary like this. Like the first value will be the last value, like we go in the backwards manner here. So first value will be this, second will be this, and third will be this. And you can see, and this is equals to 6. Okay, this is how we like convert a decimal number into binary number. This is how this thing is working. Like instead of doing it in 6 steps, what we did it into 3 steps here. Now what we will do, we will take the test case, like sorry, case 2, in which the value will be 2 to the power. Why it's looking that much big, man? Okay, what I can do is, it is case 1, so we can draw a line in between. So it will be, can use a pencil for that. I'm just drawing a boundary here so that it will be, because it is for, okay, it got a little bit covered a wide area here, I think. Just I'll do this. Okay. Now we will take the case 2, in which the power will be odd. No, yeah, the power will be odd in case 2. For that I will be using the, okay, I can use this color just to draw the line. So in this case, it is equal to 2 to the power 7. Okay, like here. So 7 in binary is triple one. So 7 in binary is equals to triple one. Okay, and again the values will be like 2 to the power 0, 2 to the power 1, and 2 to the power 2. Okay, like when we are going like in this way from right to left, the increases every time the power of 2, like 2. Okay, so the places of power of 2 every time we go in this way. And yeah, Means 7 is equals to what? 7 is equals to the 1 minute. 7 is equals to, in this case, 4 plus 2 plus 1. Okay, you can see it. 4 plus 2 plus 1. Yeah. And now we will start with the answer. Like answer will be equals to 1, like we have initialized it, so that we can multiply it with and get the answer. So answer will be in the starting is 1, and x is equals to 2 here. Okay, x is 2 and n is 7. Okay, so in the step 1, what will happen in step 1? And how we are getting these values, I will also tell you. Like I have already tell you here in the case 1 how we can get these values. So first 7 will be taken modulo with 2 here. Okay, here. So it will give 1 in the remainder. Like 7 is 2 into 3 will be 6. So 2 into 3 will be 6, and we will get 1 in the remainder, left in the remainder. Okay, that's why. That's how it is. We are taking model of it. You can see it here already. And then it will be true. Then answer will be equals to what? Answer will be equals to answer into equals to x. So x is just the base here. So 1 into 2 will be 2. Okay, so let me write step 1 here. So in the step 1, answer will become what? Answer will become 2. Okay, because the last bit is 1, so we will add the power of that power, because we want the power of 2 like 1 times also. So answer have become 2 now, and now we will do the square of the base like here, and the base is 2, so 2 into 2 will be 4. So x is now become 2 into 2, that is 4, and it is equals to 2 to the power what? 2 to the power 2. Okay, and now n has become what? N has become 3. Okay, now we will just wait a second. Again a call is coming, man. Again and again the calls are coming. Just I don't know why. When I start streaming, then call keeps coming. Man. Hello, 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 hello. I think the voice is coming now. Now let's. Yeah, we were here. So now what will happen in the step 2? Okay. just wiping my hands because it's little bit of water is present on my hand. So yeah. Now in the step one, this is done. Now in the step two, we will check for the next bit. Okay. And yeah, n has already been divided and n has become 3. And 3 in binary you already know is equals to, like, it is represented as 11. Like the bits have now become 11. Okay. Now in the step 2, when we will take modulo of it, then 3 divided by 2 I have already showed here. 3 divided by 2 will give 1. Okay. And then what will happen? Then it is equals to 1. So in the answer we will multiply it with the x, and x is what? Like x is the power. Okay. So 2 into 4 will be what? 2 into 4 will be 8 here. Okay. So answer will now become, it's not looking that good. Okay. So in the step 2, answer will now become what? Answer will now become 2 into 4 will be equals to 8. Okay. Answer will now become 8 and x will be updated again, and we will do the square of the base. So 4 into 4 will be what? 4 into 4 will be 16 here. So x is now become 16. Okay. And yeah, and it is equals to what? 2 to the power 4. Okay. Like the when we do square of the base, then it is, the power is being multiply, like it is increasing by 2 every time, like 2 to the power 2, 2 to the power 4, 2 to the power 6, 2 to the power 8, like this. Okay. And now n have become, like when we will divide it after it, so n will now become 1. Okay. Let me just see it a little, so that no confusion gets left. And then this step 3, we have done this till this, and x is already 16 and is 1. So last bit is 1. Okay. Now in the step 3, we are just end of that thing with an explanation. Now as x has become 3, okay, sorry, n has become 1, and last bit is 1. Like we excluded this, then this. Now it is 1. Okay. Now like last bit is 1, so we will add, we will multiply the answer with the x like power. So answer will be, it's not, the color of it is okay, it was a pink color, man. So answer will be equals to what there? Answer will be equals to 16 into 8, that will be equals to uh, so answer will be equals to 16 into 8, that will be equals to, yeah, 128. Okay, here it will be equals to 128. So in the answer we have stored 128. After that, what will happen? After that, the x will be, we will again do the square of the base. So 16 to 16 will be what? 16 to 16 will be, let me just check. Yeah, will be equals to 256. Okay. Now what will happen? Now n have become 0. Okay. Now the loop will not run, and we have already stored 128 in answer. So we will return what? We will return answer is equals to 128. Okay. In this case. And we can check it also here. Like if I show you in the calculator. Okay. Like 2 to the power, first we'll check for 2 to the power 6. Okay. So 2 into, like if we were doing according to that, okay, that formula. See, it is coming near to 64. And we will again, like when we take to the power 7, then it will be equal to 128. This is how we are getting it. But instead of doing it 7 steps, what we did, we did it like in 3 steps. Okay, like calculating this, the powers of taking powers of the thing. But if we were doing it, using the uh, big N approach, in which we were doing n number of operations, like if it was 2 to the power 7, then we will have to multiply it by 2, so, around 7 times. If it was around 2 to the power 100, then we will have to multiply it by, 200 times. But when we, take the binary form of the power and break it into this to the power of 2, and yeah, and we can do the things like this. Why I showed you? Because many people think that what will happen when it will be, odd, or what will happen when it will be even. So in the even case, I already told you that you have seen how the thing is working, and we are also getting at the answer. We are also getting the answer. Okay, and here in this case also, answer is equals to 128. And now what we will do, we will try to understand the code. Okay, so see how the code is working. To stop the overflow of the integer, like when we will convert it from negative to when we will convert the power from negative to positive value. Okay, because the power can be bigger. Okay, so in the same time, I would like to try to write the code again. And yeah, and to handle the negative case, like when power will be negative, to convert it into a positive power, what we will do, if n is n is less than 0, okay, then we will do this, like n will be equals to 1 by, sorry, when x is, just wait a second, okay, the power, okay, we are checking if the power is there, if power will be equals to 0, that like less than 0, then I was thinking that, because when power will be negative, then we have to do that. So yeah, when the power will be equals to 0, like less than 0, then we have to do this. And I will also remove these things. We will do it by itself. So yeah, if bin form like power is less than 0, then in that case the we'll flip the x like the base, okay, by 1 by x. After that we will reinitialize, we will change the bin form is equals to, sorry, bin form will be equals to minus of bin form, okay, like it will change the order of it from minus to plus, like it will in, like here we are inverting the base, and here we are just flipping the power from negative to positive. Okay, if it will be less than 0, then it will be negative, then we can do convert it into positive by flipping the value here. And so it will handle the cases where the values will be, where the powers will be in the negative. So okay, it will convert it automatically. And after that we will use a while loop. While what? While binary form, okay, which I've told you about, while binary form is more than 0, then it will run. Okay, till this. Inside this, what we will do, yeah, before that we also have to create a variable, like, and yeah, give it a type of double 1.0. Like the base can be in integer, or maybe in this form like double. Okay, So here it is said that we should return the answer in a double for data type. So we are using double data type. Okay. And now inside this, what we will do, we will check if, when we check for the bits of the power, if like we are checking for the bits when we have converted the power, like in the binary form, we are checking if the values of it is 1 or what. Then when the value of it will be 1, like if n modulo, like n taken modulo with 2, if it's giving 0, okay, not n, it will be equals to binary form because we have changed the name of it. So then it will be this. So if it's true, okay, like no, if it's equals to 1, so in this case, what we will do, we will add the answer is equals to, okay, is into equals to the base, that is x. Okay, after that, what we are doing, like I have showed you here, like how this thing is working. Okay, and after it, if even this condition is not true, okay, we have to every time increase the power of the base. So x will be equals to x into equals to x, like it will multiply by itself every time, like base, we are doing the square of the base. If even if this is not true, even if the last bit is not 1, okay, and also after that we will do, like we are also dividing the power every time by 2, so that we can get to the next bit. After that, we will return the answer that that will be the value which we will get after doing the power, after raising x to the power which is given. Okay, there's a semicolon missing here. Okay, okay, something is wrong. Expected was this. Uh, let's see what's getting wrong here, or maybe informing n. Let's see here, 1 by x. While it is true, if condition, and it will happen every time. If let's see where the code is getting a little bit wrong. Okay, we forgot to use the equals to sign so that when it will be run again, then it will be it will again not get the next bit for that. I think because of that, it's giving the wrong answer. Like the syntax of writing this is this, like bin form divided equals to 2. Like bin form is equals to bin form divided by 2. Okay, we have to write it like this. Just there was a slight mistake. See, it's accepted now. And now even if we do, if we take axis like this and the powers are like, okay, Let's keep it to here, and when we will try to run it, it's not a valid value of integer. Okay, I think according to the test case, it will not run. But when we will be submitting this, then it will numerical result out of range. Okay, what if it's 100, man? Then I think it should run now. Invalid. Expected x2n to have value from -1000 to 10,000 only. But n is okay. So in the text case box, like here, I think if we run for 10, then it will run easily. Okay, it is running. What if I do it like 12? Like saying the output should be, I think, between 10,000, like -10,000 to +10,000, like this. It's coming near to 4,000. If I do it like 14, then I think it will fail because the value will be more than 10,000. Yeah, you can see. And if I do this like 3, maybe it will run. Just we will wait for this. Okay. Yeah, so the output should be between -10,000 to +10,000 in this case. If when I submit it, okay, it will be accepted and there will be hidden test cases in this. Don't know how to open the test cases here which are hidden. So this is how this thing is working. Like first what we have did to control the overflow of the power when we will convert it from to like if it will be -2 to the power 30, then maybe it will be equals to 2 billion. Like it sounds a very big value to for a power. Okay. Then when we will convert it, it may overflow. So because of that, we use this long data type so that it can handle that overflow and give the right okay power in the right form. And if binary form, if power is less than 0, then we will invert first. We will invert the base. After that, we are doing binary form is equals to what? Binary form is equals to minus of binary form means if binary form is negative, then it will convert it into positive because it is already negative. That's why. And negative is equals to positive. Like you, I think we have already listened that minus minus is plus, and plus minus 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 plus minus, and plus plus is equals to plus. That's how this thing is working. And while binary form is more than 0, like it is checking while binary form is equals to 0, like when power and yeah, binary form is what? Binary form is the power when power will be more than 0. Okay, then it will run till that. And here we are checking for the bits of the power, like in the binary representation, we are checking for the bits. When we take modulo of binary form the power with 2, like any number with 2, then the if the last bit is 1, that is considered, that will be taken here, like here. The last bit is this, and we want the values like in this format. So we will exclude this. Okay, like when we break the 6 into the power of 2, it comes near to this, like 2 to the power, okay, 4 plus 2, okay, means 2 to the power 1 and 2 to the power 2. That's how it is represented like here. So when we break down the, like suppose if it's 6, okay, we are running for 2, then we can do this, like 2 to the power 6, okay. So here, in the step 1, answer will be equals to 1, like we have initialized the answer, so that we can multiply the next values with it. Okay, the next powers with it, and x is equals to 2. Okay, x was Yeah, x was 2 in the starting, but when we checked for the first bit, it was 0. Then we multiplied the base with base again. So 2 into 2 will be 4, and it is equals to 2 to the power 2, and n has now become 3. Okay. So now in the step 2, we will do answer into 1 into 4. Why? Because the next bit is 1. Okay. And 1 into 4 will be 4, and x we are again doing the base of the square of the base, so x is 16 here. After doing square of the base, like 4 into 4 will be 16, and it is equals to 2 to the power 4. So now n is equals to 1. Okay, now in the step 3, we will add 4 into 16. Okay, because the last bit is 1 here, so we will add it. 4 into 16 will be 64, and now x has become 256. But now, like, it is equals to 2, equals to the 2 to the power of 8. But now n has become 0, so now we will give the answer, which is already stored as the 64 here. And yeah, we have checked the bits like this. We wanted the power 2 plus 4. Okay, we wanted the power of 2. Uh, yeah, 2 like this, like 2 into 1 will be 2, 2 into 2 will be 4. And we want to, like, we have break the powers into this form. And yeah, did this. Okay, and this is how we are getting to the answer here. And in the case 2, the power was 7. So when we break down the power of 7 into like 2's, into the multiple of 2's, then it can come in this way. Okay, like these two the multiples. Let me tell about this. I think you guys already know it when we convert binary into decimal into binary. That's how we can check for any value. If any given value is decimal, then we can check for the values by multiplying it. Like here, if we want to check if it's 7, like what is this value is equals to. So 2 into 0 will be 2, so we will exclude that. Okay, no, we will not exclude that. Here I will mark it like this because in the example we are doing this. So yeah. But when we want to check if it's equals to 7 or what, so 2 to the power of 0 will be 1. Okay. And 2 to the power 1 will be 2. So 1 plus 2 will be 2. And 2 to the power 2 will be 4, and it is equals to 4. So 2 plus 4 will be 6, and 1 is equals to 7. Okay, it will give 7 here. This is how we can check for it. Okay, and this is it's showing the power of the it's showing the power in the binary form, and that's how we are checking the, like, if binary in the binary form, it's the last bit is 1. Okay, if the last bit is 1, then we will have to take that value, like we will have to use that bit and do this, like base will be equals to, like answer will be equals to into the power of the base, which is the current base. Okay, base value, like current base value in this will be, in the first case, it will be equals to 2 to the power 2 first. Okay, 4 in 1 into 4 is 2 to the power 2. Okay, after that it will be 16. So it will be equals to 2 to the power 4. Okay, but like f x has become 2 to the power 4, after that n is equals to 1. So step 3, n is equals to 1, like the last bit is equals to 1. Okay, so we have done 4 into 16. After that it is equals to 64. For the last bit we have done this. And after that x was updated, but we will not check for the further values because n have also become 0, and it is and it is more 2 to the power 8, and it is more than that was needed. Like we were needed 2 to the power 2 and 2 to the power 4 here, and we didn't want the 2 to the power 1 here, so we excluded that. Okay, let me just check it, and then we will revisit the second problem of today. Okay, yeah. Just wait a second. Yeah, we were right. This is how this code is working. Yeah. Okay, like instead of what I told you about in the starting, instead of doing it, doing that number of operations, we can do this in this way. Like if I show you, if in the binary exponentiation, okay, method, if we want to like get the answer of 2 to the power 7, okay, like this, then how many steps will it take to do this? See, is a free 27-bit number, okay, since 2 to the power 27. So it will take about 27 steps, okay, to compute to the power this. Compare this when we compare this with the brute force approach in which we were, writing the logic like its time complexity was equal to big of n. Okay, so it would have take around this much multiplications. Okay, while binary exponentiation reduces it to just 27 steps, a massive speed up. Let's see how it is broken. Okay, show me. Let's see how it's get broken. Right, this is binary. Okay, that's a 27-bit number. Like here, here is a dry and table like bit value, retrieving bit value. Skip the values and every time we are doing the base of the square also so that we can check for the bigger powers. Okay, like here, bit position is 7, so power will be equals to, yeah, let me see, and this is how the thing is working. Okay, 27, we have done 27 squares, 27 squares, 1 per bit. About 30 multiplications only for the bits that are 1. Okay, so total 40 operations instead of 100 crore operations. Okay, that's the magic. Binary exponentiation reduces the work from linear into exponent to logarithmic in the exponent. Okay, that's how this will reduce the thing. And yeah, the time complexity of this will be equals to big of log n. Okay, like it will be lesser than log n time complexity, and the code will run fast. So first we did this, and how this is working I have already told you. Now what we will do, we will take a 5 minutes of break. Okay, the time it took was a little bit, it took a little bit of time, but because in between I also like because of the phone calls, it was the rhythm of the things get disturbed a little bit. So yeah, first problem revisited today. Okay, first problem revisited. Name was power of x into n. Like the name of the problem is somewhat look like power into x into n. Like it feels like it is a partner type problem, but it is equals to power. Like there is an important concept that is being teased here, like how binary exponentiation works. And while talking to ChatGPT, it said that it will be used in furthermore new topics, like important topics, like Just let me check that and I will tell you. In which topics it will be used after it. So why it is important to understand this topic, like this, how this thing is working. Okay. Like this, what we're doing, we are doing number half of number and using binary representation. It comes in DSA in a repeated way, like in the binary search. Okay. After that, in bit manipulation and segment trees, sparse table, binary lifting, Fenwick tree. Okay, but fast matrix exponentiation, modular exponentiation. Like you notice one thing that there are so many algorithms. Which core idea is this? Like what? Like we have to make the problems in half and think about it as a powers of two. Okay, like it is like we are just not reading a question. Okay, learning about it. We are also understanding the DSA fundamentals. Okay, it develops a type of a fundamental thinking. Let me see if it's something is left to told tell. Maybe something is left. Mhm. Mhm. Okay, till then you guys can watch this code and try to understand it. Till let me find if something is left to be told. Mhm. Like here, okay, we are doing n divided by 2, n modulo with 2. Like we have named it as binary form. So n divided by 2 means power, power taken modulo with 2. Okay, like we are checking the remainder of it when it is divided by 2. Like if power is 13, when we will check its modulo with 2, like it will check 13 divided by 2. So in the end, it will be equals to 2, 6 by 12 and 1 will be left in the remainder. It is checking for the remainder. If in remainders, 1s are coming. Like if the last bit is 1 or 0. Okay, if it was 12, then it will be equals to 0 because 2, 6 by 12. So yeah, it will give 0 in the remainder. And here answer is equals to 1. If current bit is 1, okay, then include the current power. If current bit is 1, then include the current power, that is, and after that we are going on the next bit. Okay, after it. And even if this is not true, we are increasing the power. Okay, first the power was, like, suppose 2 to the power 1, it was 2, but then it became 2 to the power 2 here we have already seen. Okay, it was already as the 2 to the power 1. then it became 2 to the power 2, then 2 to the power 4. Like every time it is increasing by, the base is multiplying by itself. This is how it is increasing, like 2 to the power 2, 4, 8, then 16. And this is how also that this things works, like this representation works, like it shows the positions of the power of 2's, 2 to the power 0 and 2 to the power 1 is 1 here, and 1 in binary is, sorry, 2 in binary is shown like 10, and here 2 is, it is showing 2 to the power 2, so 2 to the power n is 2, plus 4 will be equals to 6. It is giving 6 here. That's how the things are working, and yeah, instead of doing n number of multiplications, we did it using binary exponentiations, like using the binary representation of the power and checking for the bits, and yeah, doing the taking those powers which is needed, okay, taking those powers which is needed and multiplying with the answer, okay, and every time we are also increasing the power, like if the last bit is not 1, okay, like see if it is equals to 2 to the power 0, then it will not add any value, like you do 2 to the power 1 here, okay, 2 to the power 1 is 2, sorry here, even if the bit was present here, okay, suppose it was present here, then it will be equals to 2 to the power 3, okay, but it will eventually become 0, okay. But I think today the Darren was good compared to yesterday, because yesterday we were just so much confused. It's been a long day without you, my friend. I never tell you all about it when I see you again. We come a long way from where we began. I never tell you all about it when I see you again. When I see you again. Ah. Okay, I think we have already took the breaks in between. So now I think I should just end the break. I like this soon, and start the revisit of the second problem of today. So break ended. Without wasting time, we can jump on to the next revisit. That's name is sort even and odd indices independently. Oh, mm, See, in this problem, what we have to do, like we have to sort even and odd indices independently. Okay. Like in this problem, even values are already at even index and odd values are already at odd index, but the order of them is like shown here is in this way. See, the even values are already on odd even index, but the order of them is like they are in decreasing order. Okay, like the even values are in decreasing order, and the odd values are on odd index, but odd values are in increasing order. What we have to do in this, we have to change the order of them. Okay, like here, instead of doing like even index values, like the even values in a decreasing manner, we have to convert it into an increasing manner here. Okay, you can see they have come now in an increasing manner, and the odd values should be in a decreasing manner. Okay, just we have to change the uh, order of the values here. Okay, they are already sorted, or even values are at even index, odd values are at odd index. So what I will do, I will remove all this and will try to write the code by own. First, what we'll do, we will create two vectors. Okay, for this, and first vector we will name it as even array. Okay, first value name it even array, and okay, second vector we will name it as odd array. Okay, inside that, what we will do, we will store the values of which are on even index or odd index. Okay, we will store those values. So for that, we can run a for loop. We said that it will go from the very first index, to the last index, and every time this will happen. And inside this, what we will check, like we will check if what? Okay, if I like index of index taken modulo with 2, if it's given 0, then it will be a even index. Okay, then just wait a second. Hello, 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 hello. Okay, I think the voice is a little bit low. Let's check it. Hello, this is that, and yeah. Okay, it's coming in a fine way, I think. Okay. So now inside this, what we are checking, if index value is odd or even. If index value is even, then we have to push back that value of nums I in even array. What we will have to push even array dot push back the current value of nums ith index. Okay, like from the zero to the last, it will go from the zero to the last index of nums array. And in the else case, okay, in the else case, if the index value is odd, then we have to push the value of nums I in odd array. Okay, odd array dot push back what? Push back the nums I value which is present on odd index. Okay. So now Now what we will do, okay, okay, we have created the else case. So in the else case, if the index value will not be even, then it will push back the value in the odd array. Okay, because the array is already sorted in the order in which the index values, like even index value, there will be even values present on that. And on the odd index, there will be odd index values present here, there. Okay. After doing this, what we will do, like we will sort, we can sort the we can sort the even array in which we have created inside that even values are present. We can sort it in a increasing order. What we will do? We will do sort even array dot begin, okay, and even array dot end, okay. So it will sort the array in the ascending order, like here, okay. Like it will sort it in a non-decreasing order. After that, we will sort odd array dot reverse begin, okay, because we want to now we want the values to be arranged in non-decreasing order, means descending order. Like the previous value will be bigger than the next value, and will go till odd array dot reverse end, okay. And after that, after doing this, we are out of the, yeah, and we have to do this outside the for loop, not inside that. After that, what we have to do, we will have to create another vector inside that. No, 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 no. Uh, uh, Let me think. Yeah, we can run a for loop again. Okay, first I will do this. If vector will be required, I will write that. If I, until when we will be calling this, we will do that if it will be needed. So yeah, we will again run a for loop, and it will go till the last index again from the first. And we already have the sorted array like here, which we will push the values of them. So now, if, okay, if index value is if I is even, okay, like I is even, index value is even, then we will push back, okay, we can push back what, sorry, nums, we can push back the values nums array of even array index, okay. And yeah, we are also supposed to create two variables here, like even and odd, so that we can increase the positions of them. Int even is equals to 0, odd is equals to 0, okay. And yeah, even are this. But wait, we can do this like nums I index, okay, is equals to what? In this case, nums I index is equals to even array even position, okay. And after that, we will do even position plus plus after this is true. So we have just write the increment operator like this instead of writing it after here. So increase the value, okay. It's just the style of writing this. And in the else case, if index value will be, sorry, if index will be odd, then nums I is equals to nums I index value will be equals to odd array, and every time odd position plus plus, so that it can check for further odd values which are in the odd array. And in the end we have to return, after this for loop ends, we have to return our nums array, which is which will be sorted in this manner. Okay, it's accepted now, and yeah, it was a these type of problems have become a little bit easy for me. I would say like I have got somewhat comfortable in these type of problems because I think I have done a lot of practice in these problems in time. I have solved some problems related like they are just connected to each other, I feel. And this is how the code is working. If I tell you what we have done, we created two vectors. First vector will store the values which will be even, and second vector will store the values which will be odd. Okay, and they are already at odd and even indices. Okay, correct odd and even indices, and then we can run a for loop which will traverse the nums array and check for the values which yeah, if the index is even, then we have to push back the value in the even array. If index is odd, okay, then we have to push back the value. Okay, this value will go in the odd array. Okay. After that, when we will have traversed the whole array, then odd values will be in the odd array and even values will be in the even array. After that, we have sorted odd array and even array. We have sorted even array in increasing manner. Like before, it was in a decreasing manner, so we have resorted it in an increasing manner, like 2, 4, 6, 8, and we have sorted odd array in the decreasing order. Okay, like here, it was in the increasing order, like 1, 3, 5, 7. After reordering it in non-increasing order, we got the values like this: 3, 1, -1, -3, -5, like this. Okay. After sorting it, what we did, we reinitialized the value of nums array like this. Like we created two variables to increase the positions of even array and odd array, and we make like two variables so that we can keep track of both of them. Like because we are starting it both of them from the 0th index. Okay, that's why. So after there, we again use the for loop to reinitialize the values of nums i. Okay, so it will run from the first to the last index of the nums array. After that, we are checking for the index numbers. Like if nums I index is even, then we have to push back the value of even array in that, like the sorted value of even array in that, and even array position plus plus. Okay, and in this case, if nums I index is odd, then we have to push back the value of sorted order array, which is sorted in non-increasing order. Okay, then we will add the odd array value in nums I at the right place and odd index plus plus every time, so that we can check for further odd values. Okay, we can put we can add further odd values and further even values. We are just checking if nums I index is odd or even, then we are doing this because we have already sorted the arrays, and after that just we are pushing the initializing the values of nums I with the arrays like this. This is how this code is working, and in the end we got the array like this in this manner. First it was the even values are on even index, odd values are on odd index. Just the order of them were different. Like even values were in decreasing order, odd values were in increasing order. After sorting it, even values come into increasing order, odd values come into decreasing order. That's how we have done this. So now I think I should take a 5 minutes of break now. So five. First I will mark it as second problem revisited. Name was sort even and odd indices independently. Sort even and odd indices. Okay. Now 5 minutes break will start, like the actual 5 minutes break will start. In this break, what I will be doing, I will hydrate myself or like stretch myself a little bit, do some stretching. Sorry. Some viewers came in between, but the number of viewers was not that much today also, because I think because the colleges are opening and schools are opening, and yeah, and it is Monday today. And the new problem that I will be picking will be, yeah, in the break time I can check for it. I think we forget to add a problem that we have already solved. Let's check for it. Okay, we haven't added this to the favorite list. But okay. And yeah, the time complexity of this code will be equals to what? It will be equals to big of n log n, because we did a sorting here also and for loops. That's why. Okay. So yeah, we are finding that problem that we are supposed to solve. All this checking. Lucid. Okay, power of fields to solve. If I say this, we can do it with using two pointers approach or binary search or bit manipulation. Okay, not this problem. Like I've saved it for another day, because in the sheet it will, yeah, according to the lectures, it will come soon. Okay, if I show you, like the name of the problem given here, when we open that problems, then the name of the problem changes. Okay, in some problems name is, I think, a little bit manipulated here, but when we open the problem, then the name of the problem shows something different. So yeah, but I remember that the problem will be uh, shown by the teacher, that how the problem will be solved, so that when I will understand that, then it will be more easier to explain these things to all of you who are watching currently, like who come on a daily basis and see things, how the things are going on. And yeah, soon I will be also, I'm thinking about that I should also make notes of the some important problems or concepts that maybe we can forget. Yeah, I have also had a talk about it with the chat GPT, and yeah, I will do that. Like today, it was supposed to create the notes of the problems, like the important problems in which important concepts were being used. You know, I will do that. I think I can do that tomorrow. But today, the okay, we have done the two revisits of two problems. The first revisit was of the problem power of x into n. Yeah, we have to submit this also so that it will be marked as revisited. Don't know, someone is maybe watching the stream, but he's just silent. So that is marked as visited. If I show you, see, the first problem that we revisited, the name of it was power of x into n, and the time complexity of it was big of n. And the second problem that we did was, sorry, the time complexity of this problem was equals to big of log n. Okay, like it means it is less than big of n. Okay, and here sort even and odd indices independently. That was the second revisit problem of today. The time complexity of this was equals to big of n. Now I'm just finding a new problem to solve. Maybe we'll solve it from the using the list, or let's say this. It is remaining from the very few past few days. 2312 231312. We will solve. Let me ask it from GPT. Maybe it will give a recommendation, or we will try to solve this problem. Okay. Never let you go, never let you go, never let you go. Ooh, don't you give up, no, 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 don't give up, no, no. No. Such just wait for 2 minutes. Let me. Oh man, it's just recommending the things that just wait. Okay, if it's not. Yeah, I think I should ask it from the him, Copilot. Brother, it's me a problem which I can do. Like you already know which family problems we are solving. Let's see what it suggests. Okay, okay. Sort it is already done then. It's already done. Okay. And yeah, we were also supposed to, in this revisit, we were supposed to write this code for the better space complexity. Yesterday, I was thinking about that, and I can solve maybe on something similar to less time to buy wholesale stock, or maybe other. Okay, best time to buy the stock second. But the teacher have told to not do that, man. I only know basic array and vectors till now. Even binary search is not started yet. Okay, maximum consecutive ones. Let's say this. This one. Okay, this is somewhat similar to, I'll say, Cadal's algorithm, because here we are we have to give like maximum count of consecutive ones. Like we have to check the thing that where the number of ones are in a continuous manner. Okay, like here the order should not be break, and we have to check what's the maximum. Like the first two digits are consecutive, and the last three digits. The maximum number of consecutive ones is three here, because one has appeared three times here, like one after another. and it is 2 because first it was 1, after that it break, after that it came near to 1 1 2. Okay, so I think in this we can create a maybe traverse the array and create a count, and it will count the values, and it will store the maximum count of the values and check. We can check. I think we can check for the previous value. If okay, let's add it to. So for that, what I can do, I think I can create a variable like int count. It will start from the zero. It will start from 0, and for yeah, we can run a for loop here, and I plus plus. Let's keep it aside, and yeah, now what we can do here is we can write a condition if if nums I value. Yeah, yeah. If nums I value, okay, if nums I value, suppose if it's equals to 1, okay, then we can add it in the count, okay, count plus plus, and yeah, and in this case, because there are only zeros and ones given here, right? Then nums I is either 1, 0 or 1. So yeah, that's why we can do the in this case, if it's not true, okay, then count will be okay, count is equals to 0. Like we can reset the count in this case, and now and I think there we can also add a yeah, like max count variable, so that we can check, and we will initialize it with maybe int min. Okay, so the farther the bigger the value will be, the more it will be far from int minimum. Means int minimum means the max negative value that we can achieve. Like it is said that mm, yeah, minus infinity. Okay, yeah. So count will reset, and we are checking every time. Like what? Mm, max count is equals to max of what? Max of count and max count. Okay. And I think now we can, yeah, it is checking for the max count value, like it is stored in the max count. Okay. And in that case, count will reset. If the value comes to 0, then count will again reset. And let me think. There should be another thing that will come here. Okay. Count 0. And in the last, we will have to return the value. Like, yeah, we will use the, ternary operator here. Like, we have to return. And yeah, we have to return what? We will write a condition if max count, okay, if max count is equals to int min, okay, like even after doing this, then in that case, if this is true, okay, if this is true, like we haven't got any length of count, or you know what did I mean? So we can return 0 in this case if this is true, okay. And in the else case, we can return count. Yeah, we can return max count, right? In the else case. But wait, man. Yeah, we can return count here, not max count. I run it. Let's try to run it. Undeclared identifier. Max. Okay. Mhm. If numSci value will be 0, then we will reset the count. Okay. Again and again. If it will be 0. Okay, it's passing one test case, man, without even using the code. Okay, that feels good. Here it's failing. We expected was 2, but why did it do that? Let's see this. Oh man, where the code is gone. Okay, now it's back. Now test result is came here. Okay, it's now fixed, man. We were trying to fix it from a very long. So in this case, if output is in the output is giving 1, expected was 2. So I think there is a mistake. Max count and count is failing this test case. If I see max count is equals to max of, just let me check. Okay, man, that's good. I think we wrote the right code for it. Wow. Yes. And I think the time complexity of this will be equals to big of n maybe. It was not that much harder problem, I will say. Time complexity of this will be equals to maybe big of n, or because function. Okay. It will be equals to big of n. Yeah. And I think it was the most optimized code for it that we wrote. Let's ask it from Copilot. Okay, brother. I already I already have done all the problems except the, yeah, max consecutive ones. Okay, but I have found it and tried to write the code by phone, and it runs and passed one test case filled second. Then I did a little bit of debugging, and after that it is working. Should I give you the code that I uh, wrote myself? Okay. It's saying this is the real DSA learning. Okay. Let's see. It will check for if any small optimization or maybe tweak in the things can be done. It said that I have written a good code. Yeah. Good point. Okay. Okay. Okay, man. Uh, Small improvement. Max count is equal to miss int min. But it's saying that max count I have initialized it with int minimum. But this is a little bit risky. Like if array will be empty, like only zeros will be present in that, then we will have to like do extra check for that. It is saying that it is better if I use max count is equals to 0. Like if I start from max count is equals to 0. Okay. Yeah, we can also initialize it with 0 because we will compare the value. The bigger the value will be, the far it will be from 0. Okay. Time complexity is this. Space complexity of this was this. Okay. Let's see, like I will ask why 0 instead of that. And can you tell me that how good the code was or how much code I was able to write myself? Okay, why 0? Okay, okay. Like initially, what we did? Initially, we put that value like the smallest possible number. Okay, into max count variable. Okay, that means if there were only zeros in the present in the array, then we have to check. Okay, when then in end we have to check a special check that max count is equals to int minimum. Okay, 0. If max count is 0, then we don't have to check. Okay, create an extra check because maximum. Okay, in maximum consecutive, if we not find that, then answer will be 0 naturally. Means initializing it with 0 is safer and cleaner. Okay, it said that I wrote 90% plus code by own. Logic was mine. Okay, like like counting ones and reset the values, placement of max update, okay, uh, debugging, okay, minor issues, okay. Can you tell me that I was thinking of it in a way of something like Cardan algorithm. Was I thinking in the right direction? Let's see what it says. Okay, ma'am. That's nice. Yeah. Cardan's algorithm used to get the maximum sum. Idea is that maintain a running sum. If sum becomes negative, then we have to reset it. Okay, then we reset it, and at every step we update the maximum sum, max consecutive ones. Okay, here we are not maintaining sum, we are maintaining consecutive ones. This count plus plus if zero. Okay, and at every step we are updating max count exactly current style. Means intuitively we are, yeah, applied the Kadans thinking. Just instead of sum we used count. That's the reason that I felt that, yeah, Kadan, that it is somewhat similar to Kadan. I felt it. How good was your thinking? Okay. 90% of logic. Okay. It is saying that I have created 90% logic using a Kadan's pattern. Yeah. Like Kadan's resets when sum is less than zero. But I am resetting it when it is equals to zero, not less than zero. Okay. And every step we are updating the max, same as Kadan. Means, okay, I was able to solve a classic Kadan variant. Okay, that was good. Uh, it is necessary to know the things like is my logic was correct or something was wrong or is something wrong in the code. Even if it's running or it being accepted, like here, it picked up the mistake that we can reinitialize it with, we can initialize it with zero also instead of this. Yeah. Because even after this, it will compare the value, the bigger value with zero. The bigger value is stored in this max count is equals to max of this. So how this thing is working? I first created two variables, int count and int max count. Okay, both are initialized with zero. I run a for loop for traversing the whole nums array. After that, I have checking if nums I value is one. Okay, then count plus plus, like it will check for every values, like for the next values. If all the next values are one, then count plus plus every time according to the number of ones that are coming one after another. Okay, and not zero comes after that. And max count is updating every time. Max count is equals to max of count and max count. Okay. So like if we run the loops two times, like I will be on second iteration, then in the max count we will store two. Okay, because the number of ones are come for two times here, and it count will increase two times. That's why. After that, when I will be on its third iteration, that means this index, second index, then it will check and this condition will fail. Then in this we will reset the count to zero. Okay, count have now become zero, but two is, two is still like the value, two is still stored in the max count. After that we will run the loop for the further values like uh, uh, fourth iteration, fifth iteration, sixth iteration. Then it will again count the number of ones. Okay, and here the number of ones are like in this format, one after another one, like in a consecutive manner. So count plus plus every time it will happen, and it will eventually come near to count is equals to 3. Then we will update the max count because the previous max count was equals to 2. So 3 is more than 2, so max count will update and it will now become 3. And we are already, you know, traverse the whole array. So now we will just return the value which will be bigger. If max count is int minimum, okay, like it's 0, then we will return 0 in this if this case is true. If there are consecutive ones, then we can return max count. Even if consecutive ones are have came only for one time, then count will increase and it will be equals to 1. Let me show you the test case. If I add this like here, okay, let's make it 0, 0 and 0. First I will check for it if it, yeah, it will give 1, okay, here, because 1 have come only one time. After that all the values were 0, like in a consecutive manner. 1 have came only one time. And here what I can do, I can, now we will see that how what will happen. Because it's not mentioned that there will be ones every time present in the array. Okay, and yeah, you can see if it was said here that, then I think that if we will be trying to add these values like only zeros, then it would have failed in that case. But there was not mentioned here that only the array will contain ones. Okay, so it is coming here to 0. If I add another test case where, like, it will be a simple case, the output will be equals to 5 because all the ones are in consecutive manner, and there are 5 ones that are coming in a consecutive manner. Number of elements will be 5, like which values are equals to 1. Okay, see, this is how this thing is working. Now I think that we will just take a 5 minutes of break. After that I will end the stream of today because according to the roadmap, I was supposed to revisit 2 problems today. After that I was supposed to do only one new problem. Okay, according to the roadmap. So yeah, so was new today. No, first new problem solved. Name was max consecutive ones. I also want to check all those parts like max consecutive ones, part 2, part 3. Let's check for it that also. So 5 minutes break started, and in the break time we will explore that. Where is that? Okay, consecutive numbers. Let's see this problem. Okay, it's something. Okay, it's even not in. We have to solve it this using SQL. This is a database type of problem. Okay, we will leave this because we are solving DSA like DSA and C++. I was talking about this. We are just exploring what are the problems given. We are human. It's been a long day. 3 consecutive hours. Okay. I think in this we will also can create a variable like odds or something, and yeah, we'll check for that. If they are coming like 3 times, then we can return it. Or if it's less than 3, then we will not return it, and we will return false in that case. So I will mark it uh, and add it to stream solve list. Okay, or maybe yeah, we can add it to this list because it's not that much harder, or also not that much very beginner level. Okay. It's been a long day without you, my friend. And I will tell you all about it when I see you again. We came a long way from where we began. Okay, it's log max consecutive ones part 2. I think this will be a little bit interesting. Okay, man, it's we can't open them. I think maybe this one also. Okay, we can open this. A is equals to 2. Given a binary array nums and it's just this 2. It's very underlined. It's been a long day without you, my friend. And I will tell you about it when I see you again. When I see you again. Ah. Executive number sum. It's marked as hard line problem. 5 is equals to 2 plus 3. 9. 9 is equals to 4 plus 5. Okay. 4 plus 5 is equals to 2 plus 3. Consecutive numbers. We'll see that later when in the maybe I think why not ask with the him can suggest more variant like mode C family type problems. I will add them to the solve list for latest screen. And yeah, the time complexity of the new problem that we did was equals to big of n. Okay, like this problem that we did, time complexity was near to big of n. You can see it here. Okay, k zeros. Array traversal, maximum average subarray. Find subarray of length k. Easy variants for streams. Third maximum number. Simple array traversal. Maintain top 3 values. Third maximum number. Let's see. Third maximum. Like the problem that we did majority element second. I think this will be somewhat similar to that, but there will be 3 candidates in this. I think of it as this. Yeah, and it's okay, man. Okay. If it's suffix thinking, maintain minimum maximum values. Let's open this. It's been a long way. Okay. The first distinct maximum is 3. Second is this. Okay. 2. You can do this, man. Array and sorting. Given an array, return the third distinct maximum number in this array. Third distinct, if the third maximum does not exist, return the maximum number. 2. Okay. So in this problem, what as far as I'm seeing that based on my current understanding, if like given an array integer nums, okay, we have to return the third distinct number, like the third different number, like the third different value, like here 3 to 1. The third different value will be 1 here. So it the output it gave 1. Okay, in that case we have to give 1. If there is no third distinct number present, like in this case, we have to return the last value, like here it is. Yeah. If okay, if the third distinct number doesn't exist, then we have to return the maximum number that is present in the array. Like here, 2 is the maximum number, so we have written that. And in the third example, we have this. But here 2 comes 2 times, 3 one time and 1 one time. But the third distinct number is 1 here. So we can return in output as 1. And as just in 5 minutes, I will be ending the stream. Okay, we can write it with using a big of n solution. So I will mark it for to solve, stream solve. Okay. I have not added it in the list where, like I have created different lists. If I open, let me open this. Come on, man. Don't know why internet works. Internet is not working good in Brave browser. So yeah, in stream solve, I have like added those problems which I can pick on stream, like in a quick waves. Yeah, and there is a list which I have created like to solve here. The problems are like problems which will come in the next topics, not yet, but I have chosen those because those problems are good. I feel about them and like this, and it is the list like when I will be running out of time, like stream got stretched a little bit or more. Then I will these problems like these are very easy level problems that we can do when we will be running out of time in the stream and stream gets stressed a little bit. In that situation, we will do that. So now I will summarize the stream. Okay, what we did into the stream, we revisited two new problems. Sorry, we revisited two problems. The first one was power of x into n. we solved it, and we also did the explanation of it, like here. Okay, we did a explanation, like we discussed test case where power was first test case where power was 2 to the power 7, like 2 to the power 6, sorry, and we did it like here, how the answer will come to 64 when we use binary exponentiation, and when the power of 2 will be 7, then how when the power will be odd, like here 7 is odd. Okay, so how we can do this and calculate the answer, and this is how what we done. And after that, I will tell, yeah, the time complexity of the code of the first problem that we revisited. The name was power of x into n. Time complexity was big of log n. Okay, like it's less than big of n. And here after that, we saw revisited the second problem of today. Name was sort even and odd indices independently. We solved it in around big of n time complexity because there was just for loops used here, and yeah, being used here. No. We solved it in big of n log n complexity because there was sorting function also used here. So it increased the time complexity from big of n to big of n log n. Okay. After that, I tried to solve the next new problem that was, sorry, the after the second revisit, I solved a new problem that's name was maximum consecutive ones, and the time complexity of this was equals to big of n. Okay, so in total, I revisited two problems. Like first one was power of x into n. Second one was sort even and odd in the indices independently. After that, I solved the first new problem of today's stream. That was max consecutive ones. In total, we revisited two problems and did one new problem today. Okay, that was all for today's stream. And yeah, if you learned something from the stream, make sure to like the stream, and yeah, and subscribe to the channel only if you feel that you have learned something from the stream or getting some value. Then you can consider subscribing, and if you yeah, then you can consider subscribing. I will not say that you should directly subscribe to the channel just because I'm saying to subscribe. You can subscribe. You can consider subscribing when you feel that you learned something from the stream or getting some value from the videos or stream that I create. And then when you will be subscribed, then you know when I will be live again or create a new video, then yeah, then you can then it will be visible on your home feed or notification section. Then you can come back on the stream again and have interactions with me, or like can see me doing explanations or explaining things and can have interaction with me. Okay, and please do give reviews in the comment section also, like what things I can improve, what new segments should I add, and yeah, what things I'm doing good at. Okay, so this was all for today's stream, and in the end, I will say that if you learn, what you have to do till then, you have to keep learning and keep exploring, and yeah, keep grinding.